Okay, so in this equation, we have 2 sine of x minus cosecant of x is equal to -1, and we want to solve this for all x's over the interval 0 to 2 pi inclusive. And that means that we know we're working in radians as opposed to degrees. So first thing we want to do is rewrite this all in the same trig function. So we're going to use a reciprocal identity to change this cosecant of x into a sine of x. So that will give us 2 sine of x minus 1 divided by sine of x, and that equals -1. Okay, now we need a common denominator in order to combine these two terms. So I'm going to multiply 2 sine of x by sine of x over sine of x so that I can get a common denominator. And that's -1 over sine of x is equal to -1. So now when we combine these numerators, 2 times sine of x is 2 sine squared x divided by sine of x minus 1 over sine of x equals -1. And now that we have a least common denominator, we can subtract the numerator. So 2 sine squared x minus 1 all divided by sine of x is equal to -1. And from here we can go ahead and multiply both sides by sine of x, or you could think about it as cross multiplying to solve the proportion, either way. So that'll leave us with a 2 sine squared x minus 1 is equal to negative sine of x. And this is quadratic with that sine squared x. So we're going to set this equal to 0. So 2 sine squared x, and then we add the sine of x to this side. And then that's -1 is equal to 0. Okay, from here we want to either factor or use the quadratic formula to solve this quadratic. And I'm going to go ahead and factor. So I'm going to just, to make this easier to look at, I'm going to rewrite this letting b represent the sine of x. So instead of 2 sine squared, I'll have 2b squared, and then plus b instead of plus sine, and then -1 equals 0. All I did was substitute b in place of sine of x to make the factoring a little easier. So next I'm going to use my crisscross and my box in order to factor this quadratic trinomial. If you have a different factoring method you prefer, absolutely go ahead and use it. But the way that my students factor, we multiply the first and last term. So 2b squared times -1 goes in the top of the crisscross. Then the middle term goes in the bottom of the crisscross. And we're looking for factors of -2b squared that add to equal b. And that would be a 2b and a -b. So that 2b times -b, that multiplies to give you -2b squared. 2b plus -b adds to give you the b on the bottom. And those will go in these two boxes. Then the first term, the quadratic term, goes in the first box, 2b squared. The constant, -1, goes in the last box. And then we're going to look for the GCF going across each row and up and down each column. So 2b squared and 2b, they have a 2b as their GCF. -b and -1 have a -1. 2b squared and -b have a b in common. 2b and -1 have just a 1. And so these are our factors, b plus 1 and 2b minus 1. So now when I go to write that in my factored form, I'm going to recall that b was just temporarily representing the sine of x. So these factors are going to be sine of x plus 1. That's the b plus 1 when I put sine of x back in. And then the 2b minus 1 is going to be written as 2 sine of x minus 1 equals 0. And then it's completely factored, so I can use my zero product property to set each factor equal to 0 and solve for x. So in this case, I subtract 1 from both sides, and sine of x equals -1. We take the inverse of both sides, and x equals the arc sine of -1. Then on this side, we have 2 sine of x minus 1 equals 0. And so sine of x is equal to 1/2. And we take the inverse of both sides, and we get sine, oh, there's a big glare. Let's see if we can move that out of the way to get past that glare. So then x equals the arc sine of 1/2. Boy, that's a terrible glare. Okay. So from here, we want to look at the unit circle and find all of the y coordinates on the unit circle where there's a 1/2. And that would be in quadrant 1. That would be located at pi over 6. Okay, then sine is also positive in quadrant 2. And so 5 pi over 6 would be our second solution. And then looking over at this one, where arc sine of -1, we're looking for a y value of -1, and that would be at 3 pi over 2 along the negative y-axis. That's where we have a coordinate of 0, -1, and so the arc sine would be -1. Okay, next we want to check these in the graphing calculator. So we're going to go ahead and grab that graphing calculator, and we're going to check that we're in radian mode, and then we're going to store pi over 6 as x, and we want to type in our original equation, so 2 sine of x minus, but then we don't have a button for cosecant. So we just have buttons for sine, cosine, and tangent. So to use cosecant in the calculator, we're going to need to use the reciprocal identity, 1 divided by the sine of x. And then second math, number 1 gets the equal sign, and -1. So this is our 2 sine x minus cosecant of x equals -1. And when we press enter, when there's something from the test menu there, like an equal sign, if the calculator says 1, that means it checks. And if it says 0, that means it doesn't check. So we press enter, and we get a 1. And so pi over 6 is a solution. So next we're going to check 5 pi over 6. Whoops, forgot to store it. So 5 pi over 6, and then store x, enter. And we're going to arrow up till we find that equation, so we don't have to type the whole thing back in, and press enter, and it copies it for us, and then enter again, and we get a 1. And so 5 pi over 6 also checks. Okay, now last but not least, we want to check 3 pi over 2. So we type in 3 pi over 2, store as x, enter, and then we arrow up to grab that equation and press enter, and we get a 1, and so 3 pi over 2 also checks.